Welcome to part 3 of the Atik introductory tutorial. In this part I'll cover how to use the software, including the binning function and subframing. Lots of information here, so let's get on with it.
Well done. Obviously we've got the USB drivers on the laptop at the moment. What we're going to need is our 12 volt power supply. So I've used one of our universal adapters, our 12 volt adapters. We're going to need a USB lead. No. And just take the one out of this packet here. These are mini USB leads. So they've got the smaller connector on the camera side. Just need to find a place to pop that into the laptop. We're just going to pop that into the USB connector on the back. At some point I may need to put my glasses on. Can I get in there? Right, we're in. And let's pop the power supply in, and then immediately the laptop recognises that we've got the camera connected up, and it's installing the device driver software. So what we've done before with the installation packages is that we've pre-installed the drivers, and it's a process that means it's in the driver cache within Windows, and then when Windows sees that device, it then goes ahead and installs the correct driver for it. So there, installing the driver. It's not a completely instant process. Microsoft being what it is quite possibly now checking all possible update sites before it's going to accept that the driver we've just installed is the correct one. There we go. Hopefully it's not going to take too much longer. So what I've just put on the table here is a little tripod which we can just rest the camera on. Let's just do that in there actually. Put that in there now. You can probably hear there's a fan on the camera. The cameras themselves are all cooled CCD cameras. That does mean to say that there's a lot of heat to dissipate within the camera as we pump it out of the CCD itself. So there is a fan there to move the air around the heat sinks that are inside the camera. Okay, so there we go. We've installed an Atik 428EX camera. Okay, what I'm going to do now is run our software we've just installed. It's called Artemis Capture. You can find it either if Windows has located it within the frequently used programs section, it'll be there. Otherwise, you may need to come down and find it in the Artemis CCD directory, and it'll be there, Artemis Capture. So we just let that run, and it'll pick up the camera. There we go. This is what you'll see the first time you run the software. Especially, we've made this software to be simple and straightforward to use on the laptop, outside at a telescope. So it's got a very straightforward and simple user interface. At the top here is a row of icons, which basically gives us access to all the frequently used bits of functionality we're going to need. First thing I'm going to suggest we do is open up the exposure dialog. So it's this one. If you hover over it, it says exposure. So pop that open, and it gives us some information on what the image parameters are going to be when we go to take an image. So at the moment on this one, I've got the exposure set to 2 seconds. Now with these pinhole lenses, very little light is being let through onto the camera itself, so we want to set the exposure to quite a large value. So 2 seconds is fine here. Delay only comes into effect if we take a sequence of exposures, so we'll talk about that later. There's a couple of little checkboxes here that I'll just mention at this stage. There's preview, which we can check will be a slightly quicker download. Image quality isn't as good, so for astronomy, probably best if we just don't check that at all. Lock just stops us from changing anything. If we've taken a sequence of images, it's quite handy just to know that you haven't accidentally changed anything. But again, this moment we're not going to use that. So the first thing to do really is to take a single image. So what we're going to do is come over on this side, and this little camera icon here says snapshot. We press it. What we're going to do is take an image. We're going to expose the camera for 2 seconds, and then the download is going to take about 2 or 3 seconds. And see, we've got an image. Images through pinhole lenses are pretty fuzzy at the best of times, so this is okay one. It's a fairly fuzzy image. What we're actually seeing there is a wall planner, a year planner chart on the wall opposite to where I am at the moment, and we can see it's can't see really anything there, but it's laid out in weeks and in months. Okay, so what I want to do now is to talk you through some of the basic functionality of the software, the sorts of things it's useful to have a play around with and learn before you go outside and use this at the telescope. Okay, so with the pinhole lens itself, we haven't got an awful lot of resolution. What we can do is just with the mouse zoom button on this piece of software, we can zoom in and out of this image so we can see what it is we've got. One of the things I want to talk you through is to get an image at full resolution. It takes about 2 to 3 seconds on the download. That can be a relatively long length of time if you're trying to find an object in the sky. So first thing to kind of get used to doing is to use binning with on the camera itself. So that's used by selecting this bin x-axis, X checkbox. So we're going to choose a bin by 4. What that's going to do is going to collect 4 pixels by 4 pixels and combine them all into one, so it's going to be 16 times the number of pixels. I've got bin y set to equals x here, so bin y in this case is 4, so it's going to be a square bin of 4 by 4 pixels. Because we're adding all these pixels together, we don't need as long an integration time, so I'm going to set that down to 0.3 seconds there. I'll take another image. It should be slightly quicker to download this one. Okay. Now what I haven't got is because I've got the screen dialog, I'm not actually seeing when this is updated, so I'll just make that so I can see what I'm doing there. Okay, so we'll just do it again. So we can see the status of the camera down by this bottom section here. It's saying at the moment it's idle. So if we do a single image, it goes to downloading and then goes back to idle again. So it's that quick now to get a single image. It's probably worthwhile just noting at the moment we've got a dust mote or something on the image here. Because there's a pinhole lens, anything in between the pinhole itself and the CCD is going to cast a in-focus shadow on top of the CCD. So it might be worthwhile when you come to do this to take a blower or a brush or something and just a photographic cleaner and just clean that front window if we want to get rid of all the dust on top of the front of the camera. And as it will be shipped to you, there will be some dust accumulating on the front of that front of the optical window. It just needs a puff of air or something just to clean that up. Also probably worthwhile noticing that when we come to use this with a telescope at f5 or f8 or something, then you don't see the degree in any way of dust that you will do if you're using this with a pinhole lens. So if you do see some dust with the pinhole lens, don't get worried about it. It's just something that is a function of using these very, very tiny pinhole lenses. Okay, so what I want to show you next, probably the display dialog. What we've got here is a camera with a 16-bit A to D converter on it. So we can call pixel values down from 0 all the way up to 65,000. Of the screen, with the best will in the world, this isn't the best laptop screen I'm looking at. It's probably got a dynamic range of 8 bits or 255 pixel values. So we need some way in which to scale the range we've got from the camera to the range in which we've got from the screen itself. And this is where this display dialog comes in. So at the moment we see we've got it on auto stretch and we've got a little histogram window at the top, and it's telling us at the moment that all our pixel values are basically very low. So how can we get around that? Well, we could expose this chip for a bit longer. If we go back up to 2 seconds again, take another full image. Again, this takes a bit longer because it's taking a 2-second exposure this time. I would say the histogram now is starting to expand a bit. When you come to do some astronomy with this, it's worthwhile looking at the histogram values. So if you've got some sky glow, some light pollution, obviously you don't want to get to the point where the sky itself is taking up half the dynamic range. So shorten the exposures in that time. Make sure the sky background doesn't come up much above 10,000 counts at absolute maximum. And you'll also get a chance to see what the higher pixel values are as well. So get a chance not to let the brighter stars saturate too much. Also on this, what we can do is we've got auto stretch selected. If we click auto stretch off, then we have two slider buttons here, and we can use these to explore the full dynamic range of the camera. So if we do full range, this is what the full range image looks like. Then we can pull these in and just kind of see just the range where the camera is actually recording pixel values. So there you can see there's a little more clearly. We've got the wall planner there, we've got some brick walling down there, and the rest of it is magnolia painted and rather bland. So if we were trying to go to the telescope now and find our way around the sky, trying to centre a deep sky object, the thing to do is to set a high binning value. Let's do something outrageous. Let's do 8 by 8 binning and set a small exposure value so we can get this doing quickly. Okay, what I need to do there, obviously intentional error, I need to click on auto stretch in order to let the computer display the image the best it can. So this is the auto stretch image. Then what's useful doing is then clicking the loop button, and this will just collect images continuously, and the space between the images is given by this delay function. And we should be able to say, if we were moving a telescope around at the moment, we'd be able to see kind of what we're moving around. This, sadly, I've picked a part of our unit that is rather dull, so it's just really got that wall planner on that wall there. So the first thing maybe to do is to kind of get the camera pointing in a correct direction. There's a lot involved in getting a camera working at a telescope. One of the things we also need to think about is getting the camera focused. For focusing, it's probably this method of taking a whole image highly binned will work for rough focusing, and we'll start to be able to see the stars come to focus. But for fine focusing, we'll need a slightly different method. In that case, what I would suggest you do is use the region of interest or the subframing if successful. So if we take a piece of the wall planner here that's got some information on it, we'll just drag a little, this is a right click, and drag a box around that section. What we've got then, if we take a single image, it just downloads that information, and we can zoom in it using the wheel on the mouse. Also, now we've got the display icon open, we can zoom into it using the zoom on that thing. And grabbing around, we can move that section within our display window. Okay, so we're not going to see an awful lot of detail in this because this is a pinhole lens and it's innately fairly fuzzy. But if we were going to focus, probably best after we know we've got a star in the field of view, is to subframe around the star, go back to 1 by 1 binning. You may have to do this slightly more slowly. So in this case it's 2 seconds. Ideally when you come to focus, it's nice to use 0.5. Let's try 0.5 to see what we get. And put it into loop mode. Now, if we were downloading a full image, it was going to take 2.5 seconds to download. Because we've only got a very small subframe, we've got a much quicker download. If we had the resolution within the lens, which we haven't really at this point, we'd be able to focus it up. And well, if this was on a telescope, focus the telescope. Right then, so that's a very quick overview of the software we have. What I'm just going to go back is just do a quick 4x4 of this image. This shows one little neat feature of a pinhole lens. Obviously we haven't got things like aperture and we haven't got things like focus on a pinhole lens. What we do have is zoom, so you can actually pull this in and out, and it does. I've just let too much light into it. Have a play around with this. They've got pinhole lenses themselves are quite good fun. What you will find, if I made this slightly better without the light leaks that this one does have, what you find is if you move it backwards and forwards, you get a zoom effect. Okay, I think that's one more part I will just touch on the software, just so you've seen it. All our cameras are cooled CCD cameras, and to get the best out of them, you need to set the cooling on. The cooling doesn't come on by default. You've got this little icon here. Press that, and we have the cooler on function. We can press cooler at the moment we're seeing the status off, and we can set the set point using up and down keys. Cooler on will then set the camera to cooling. And if I'd have done this at the very outset, what we find is a less grainy image and slightly better image quality. I did say that all our cameras have cooling. I better just rephrase that. The Atik GP doesn't have any cooling, but then it's meant as a planetary imager and a guide camera. The Atik Titan has cooling, but it's on all the time. So as you connect the 12-volt power, it's then on. But the rest of the cameras have this set point cooling, and we can set the cooling and let it equilibrate to a temperature. So that's what it's doing there. What it's not doing is telling us that it's actually cooling. That's because it's downloading continuously. We just need to allow it some time there when it's not downloading to actually report the temperature it's coming up at. So we just wait a moment for that. So we see now it's down to 18 degrees, and it'll go down to the 1.9 degrees that we've set it to.
Okay, that's the end of part 3 of the Getting Started tutorial. I hope you found the information in there useful. In part 4, we'll cover the cooling functions of the cameras and how to shut down the software. So that's part 4 coming up shortly.